Good morning everyone. This is Vijayasri from CSIT department in MLR Institute of Technology. In today's session, we are going to learn about operators in C. Overview of this session: the operators are classified into arithmetic operators, relational, logical, increment and decrement operators, design operator, bitwise operator and conditional operator. What is an operator? An operator is a symbol used to perform arithmetic and logical operations in a program. That means an operator is a special symbol that tells the compiler to perform mathematical or logical operation. Let us suppose here we consider an expression like C equal to A plus B, where plus is the operator and AB are the operands. When we gave an expression like this, then the compiler understands that it has to perform a plus operation between these two operands. These are also called as variables. If suppose A value is 2 and B value is 3 and the expression is C equal to A plus B, automatically the compiler substitutes the value 2 as A value as 2 and B as 3. So the result is 5. Arithmetic operators. Arithmetic operators are the symbols that are used to perform some basic mathematical operations like addition, subtraction, multiplication, division and modulus. Like here we have plus represents addition. So here I consider the example 10 and 5. 10 plus 5, the value is 15. Subtraction, it tells that it has to subtract the value. So here I consider 10 and 5, 10 minus 5, so it gives the value as 5. If we consider an example, here we declare the variables A, B, C, D, F, G, and here we have taken two values A and B as 12 and 2, where A value is 12 and B value is 2. So here we have an expression C equal to A plus B. C equal to A plus B. That means plus is an operator tells to the compiler to perform addition between these two variables, those are A and B, where A value is 12 and B value is 2. So the result is 14. Here we have 14. And next is D equal to A minus B, where the expression is D equal to A minus B. That means this symbol tells to the compiler to subtract the value, where A value is 12 and B value is 2. After performing that expression, we will get the result as 10. Then E equal to A into B, where A is 12 and B is 2. So the value is 24. Division, F is equal to A by B. So that is A value is 12 and B value is 2. So the value is 6. Coming to modulus, this gives the coefficient, where modulus gives the remainder. So G is equal to A mod B, where A value is 12 and B value is 2. So the result is 0. If we do that, 12, 2, 12, 6, 12, 0. This is the coefficient, this is the remainder. If we want this as the output, then we have to use the symbol called modulus, gives the remainder. Then relational operators. Next operator is the relational operator. Relational operator are the symbols used to compare two values. So it checks the relation between two values. If the relation between those two values are true, it is represented by the binary value 1. If the relation between those two values are false, it is represented with the binary value 0. So the relational operators are less than, greater than, less than or equal to, greater than or equal to, not equal to. Then, if we consider this, less than returns true if the first value is smaller than the second value. If we consider this example, the first value is 10 and the second value is 5. Second value is 5, where it gives the value true when the first value is less than the second value. But here the first value is greater, so the result is false. False is represented with the value 0. Then greater than, if we consider here 10 greater than 5, yes, 10 greater than 5 is true. So the true is represented with the binary value 1. If we consider the example, here those two values are, here I declare the values, variables x and y, and the values are 5 and 7. Where if we consider the statement printf x greater than y, where x is 5 and y is 7. Is 5 greater than 7? No, false. So it has to return the value 0. The result is 0. Here we got 0. Next is x greater than or equal to y, where x value is 5 and y value is 7. Is 5 greater than or equal to 7? No, false. So false is represented with the binary value 0. So here we got value 0. Then printf x less than y, where x value is 5, and y value is 7. Here we have an expression called x less than y, where x is 5 and y is 7. 5 less than 7, yes, 5 is less than 7, condition is true. So if it is true, it is represented with the binary value 1. So here we got the output as 1. Then x less than or equal to y. So 5 less than or equal to 7. Yes, this expression is also true. So here the result is 1. X equal to y. It compares whether those two values are equal or not. Where x value is 5 and y value is 7. These two values are not equal. False. The condition is false. So it is represented with the binary value 0. So here we got the output as 0. Then x not equal to y. Yes, x not equal to y, where x value is 5, 5 not equal to 7, y value is 7. Yes, condition is true. So if the condition is true, it has to give the result as 1, because true is always represented with the binary value 1. Logical operators. Logical operators are logical AND, logical OR, and logical NOT. Logical AND is true when both the conditions are true. Logical AND means it combines one or more conditions into one statement. Logical AND returns true if all the conditions are true. If we are using this, we have to will get the result as true if all the conditions in that is true. Otherwise it returns false. Coming to logical OR, if any one condition is true, it will return the value as true. Logical NOT, if the condition is true, the result is false. If the condition is false, the result is true. Now, if we consider the example, here I have taken the values of A, B, C as A value is 5, B value is 5, and C value is 10. So, here I am using the expression is A equal to B. So, here A value is 5, 5 equal to 5, B value is 5. Yes, this condition is true. And one more condition I have, that is C greater than B, where C value is 10 and B value is 5. I combined these two conditions using a logical AND operator. Logical AND operator gives the value true when all the conditions in it are true. So here A equal to B, 5 equal to 5. Yes, condition is true. Then we have one more, that is C greater than B, 10 greater than 5. Yes, this is also true. I have combined these two using logical AND. It will give the value true when both the conditions are true. So here it is true. True is always represented with the binary value 1. So here we got 1. Then next one is A equal to B, A equal to B, or C less than B. We are using a OR operator. OR means returns false if all the conditions are false. Otherwise returns true. It will give the value, logical OR gives return value as false if all the conditions are false. If any one condition is true, then the result of that logical OR operator is true. So here 5 equal to 5. Yes, condition is true. Or we are using a logical OR operator. C, where C value is 10, 10 less than B. B is 5. This is false. But it will give the value as true. Why? Because if one condition is true, when we are using a logical OR, if one condition is true, the result of that expression is true. So here we got true. Then double equal to, so here we have double equal. Let us suppose A double equal B. Here A value is 5 and B value is 5. Yes, the condition is true. So if the condition is true, it has to return the value 1. Then let us suppose here I am giving not equal. Not equal. A equal to B. So when we are using a not, if the condition is true, the result is false. If the condition is false, the result is true. So if we consider here 5 equal to 5, yes, it is true. This condition is true. But here I am using not. Before that expression, I am using logical not. So if the expression is true, I am using a logical not. The result of this is false. Because if it is true, it gives the value as false. If it is false, the result is true. Increment and decrement operator. Increment and decrement operators are called the unary operator. Unary operator means it performs operation on only one operand. So it needs only one operand. So increment means increment is always represented with the symbol plus plus and decrement is represented with minus minus. Increment means it adds 1 to existing value, whereas decrement means it subtracts 1 to the existing value. So increment operator adds 1 to the existing value, decrement operator subtracts 1 from the existing value. So increment is represented with the symbol plus plus, adds 1 to the existing value. Adds 1 to the existing value. Here we have A equal to 5. So A equal to 5. I am using increment operator A plus plus. That we can write as A equal to A plus 1. Where A value is 5. So it is 6. Decrement operator subtracts 1 from the existing value. A value is 5. I am using a decrement A minus minus. A minus minus. This represents that it has to subtract 1 from the existing value. Here the existing value is 7. It subtracts 1. So the value is 4. These increment and decrement operators are divided into two types. Post increment and pre-increment. Post increment, pre-increment, post decrement and pre-decrement. So here we'll see in this slide, we'll see about post increment and post decrement. Post increment is always represented with a plus plus after the operand. So it is a post increment. A plus plus is the post increment. A minus minus is the post decrement. So in this example, here I consider the variables are I and j, where I value is 5. Then I have given expression j is equal to I plus plus, where plus plus is the increment operator, but here we have a post increment. Post increment means I plus plus, pre-increment means plus plus of I. So this increment operator adds 1 to the existing value. So here post decrement, it assigns the value first, then increment happens. The difference between pre-increment and post increment is here I plus plus, it assigns the value first, then increment happens. Coming to pre-increment, it adds 1 first and then assigns to the value. So here we have a post increment. I value is 5. this I value is assigned to the variable j, then increments. So now this value is so here j I plus plus, where I value is 5, that 5 is assigned to the variable j, then increment takes place. So then 5 plus 1, so it is 6. This is I. If you observe this, here we have I equal to 5 and j, where j is equal to I plus plus. That means I value is assigned to the variable j. So I value is 5, it is assigned to the variable j. So here we got output j equal to 5. Then after assigning, increment has to be happened. So 5 plus 1, now it is 6. That I value is 6. Coming to post decrement, the same. Here I value is 5 and j has given expression as j equal to I minus minus, where minus minus is the post decrement. That means it subtracts 1 from the existing value. So if it is a post decrement, here first I value is assigned to the variable j. Now j becomes 5. After assigning, then decrement has to be happen to the existing value. Here the existing value is 5 minus minus, that means we have to subtract 1. So here we got 4. So I value is 4. If we observe in this example, here I value is 5 and j is equal to I minus minus. I minus minus, where it is a post decrement, that means first I value is assigned to the variable j. That means I value is 5, it is assigned to the variable j. So here we got output j as 5. After assigning, decrement has to be happen to the existing value. So our existing value is 5, 5 minus 1, so the value is 4. So here we got I equal to 4. Pre-increment. Pre-increment means first increment has to be take place, then it assigns to the value. So here I consider I equal to 5, then the expression j is equal to plus plus of 1, where plus plus of I, where plus plus is the pre-increment. That means first we have to add 1 to the existing value. Existing value is I, where I value is 5. So it is 6. So this is assigned to the variable j. So here we got plus plus of I, where I value is 5. Pre-increment, that means plus 1 to the existing value 5. So the value is, j value is 6. So in the same way, pre-decrement, first it subtracts 1 from the existing value, then assigns to the variable. So here we have I value as 5. Pre-decrement, that means it has to subtract 1 from the existing value. So here we got 4 is assigned to the variable j. Why? Because j equal to minus minus of I. Bitwise operators. Bitwise operators are used to perform bit level operations. Bit level operations means 0 and 1. Will perform these operations on these two values. Because C programming language, it converts everything into zeros and ones. When we use bitwise operators, the operations are performed based on the binary values. These two are the binary values which we are going to perform bitwise operators on these two binary values. Bitwise operators are bitwise AND, OR, XOR, NOT, left shift, right shift. So bitwise AND. Bitwise AND, here we consider the example as A equal to 10, B equal to 12. So convert these two values into binary first. So 10 binary value is, so here I am considering 4-bit representation, where 10 binary value is 1010. Then 12, convert this 12 decimal value into binary value, that is 1100. if we are performing bitwise AND on these two binary values, it will give the value 1 when both bits are 1s, otherwise 0. So here we have 0 0, so it is 0, 1 0 0, 0 1 0, 1 1 1. It gives the value 1 when both bits are 1, otherwise 0. So if we convert this into decimal, the value, the decimal value of this binary is 8. Bitwise OR. The output of bitwise OR is 1 if at least one corresponding bit of those two operands is 1. If we have at least one corresponding bit is 1, then we'll get the result as 1. Consider the same example. Here A value is 10 and B value is 12. Take 4-bit representation. 4-bit representation is represented as, so convert 10 into binary, that is 1 0 1 0. 12 into binary, that is 1 1 0 0. If we perform bitwise OR between these two operands, it will give 1 if there is one corresponding bit is 1. So if we have 1 at least in those two operands, we'll get the result as 1. 0 0 is 0. Here we have 1 0, so the result is 1. Why? Because we are using a bitwise OR. 0 1, the result is 1. 1 1 1. So if we convert this into decimal, binary into decimal, so it is 14. So here we got the value as 14. Then bitwise XOR. The result of bitwise XOR is 1 if the corresponding bits of two operands are opposite. If we have 0 1, then the result of this is 1. If we have 0 0, the result of this is 0. The result of bitwise XOR operator is 1 if the corresponding bits of two operands are opposite. If we have same value, same operands, then the value is 0. Let us consider the same example. Take the same decimal value. A value is 10 and B value is 12. So if we convert A into binary, it is 1 0 1 0, 12 1 1 0 0. So if we have two opposite bits, if we have 0 1, then XOR value is 1. 0 0, it is 0. 1 0, it is 1. 0 1, we have two opposite bits, then it is 1. Here 1 1, those are same. If we have a same bits, then the result of XOR is 0. If we convert this into decimal, the result of this is 6. So here we got 6. Then left shift. Left shift operator shift all bits left by a certain number of specified bits. The bit position that has been vacated by left shift operator are filled with zeros. The symbol of this left shift operator is this one. So if we consider it is a unary operator, it performs on one operand. Now here we have A value as 10. If we convert 10 into binary, it is 1 0 1 0. It is a 4-bit representation. Consider 8-bit representation. So 1 0 1 0. The remaining 4 bits are filled with zeros. So this is 8-bit representation for the decimal value 10. It is left shift 1. It has to shift left by one position. So it is 0 0 0 0 1 0 1 0. The remaining vacant bit is filled with 0. So it is 2 to the power of 0. 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. So 2 to the power of 4 value is 16, 2 to the power of 2 value is 4. So it is 20. So the value is 20. Right shift operator. Right shift operator shifts all the bits to the right by a specified number of positions, and it is represented with the symbol. Here we consider the decimal value of A is 10. If we convert this 10, that is 1010. That is a 4-bit representation. Consider a 8-bit. That means the remaining 4 bits are filled with zeros. It is right shift 1. That means it has to be shifted to its position by 1. So this 1 bit get discarded. Then 1, 0, 1, 0, 0, 0, and the remaining position is filled with zeros. So it is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, where 2 to the power of 2 is 4, 2 to the power of 0, any value to the power of 0 is 1. So the value is 5. So here we got the output as 5. Then assign operator. Assign operator is represented with the symbol equal to. Let us suppose if A equal to 15. Here we have an example, A equal to 15. That means it assigns right hand side value to the left hand side variable. So here A value is 15. Let us suppose if we have A plus equal to. So this represents add both the left and right hand side value and stores the result in the left hand side variable. Let us suppose A plus equal to 10. We can write this as A equal to A plus 10. Here A value is 15. 15 plus 10. So here we got 25. So subtract minus equal to, that means it subtract the right hand side value from the left hand side variable and stores the result in the left hand side variable. Conditional operator. Conditional operator is also known as a ternary operator. This conditional statement are used for decision making, depends upon the expression. Conditional operator uses two symbols, that is question mark and colon. A conditional operator works on 3 operands. It needs a 3 operands. That's why it is called as a ternary operator. So always this is the first expression, then this is a true part, and here we have a false part. These two are separated by a symbol called colon. The behavior of conditional operator is similar to the if-else statement. If-else statement is also called as a decision-making statement. The syntax of conditional operator, as I told you, first is the expression. Here we have, in this example, we have expression, then expression 2 and expression 3. These are the 3 operands. That's why conditional operator is also known as a ternary operator. In this example, here I declare a variable called n and enter n value. Here I gave n value as 4. I want to check whether the given value is even number or odd number. I am using a conditional operator. If we want to use a conditional operator, there must be a 3 expressions. The first one is the condition, second is the true part, and the third is the false part. So here the expression is n mod 2, where n value is 4, 4 mod 2 equal to 0. The symbol for conditional operator is question mark and then colon. So here we have to give the true part, whether it is a even number or odd number. Printf even number, this is the true part, and a false part, printf odd number, and these are separated by a colon. Here we have a colon. So n value is 4, 4 mod 2 equal to 0. Yes, expression is true. So the control goes to true part and it prints 4 is a even number. If we give n value as 5 modulus 2, is it equal to 0? No. The condition is false. So the control goes to false part and executes 5 is odd number. Then special operators are size of operator, pointer operator, comma and dot operator. Size of operator is used to find how much memory that a particular variable occupies, depends on the value which we are passing to that variable. Let us suppose in this example int n equal to 2, where I am passing an integer value to the variable n. If I want to find how much memory that particular variable occupies, then we have to use size of operator. So in this example, value is 2. Then I want to find how much memory does that n occupies. So printf size of n, where n is having a integer value. So the result is 4. Why? Because integer value occupies 4 bytes of memory. Then pointer operator is used to define point variables in a C programming language. Comma operator, which is used to separate declaring variables or expressions in a function call. Then dot operator is used to access members of structures or unions. In this session, we have learned about operators like arithmetic, relational, logical, conditional operator, bitwise operator, size of special operator, in that size of pointer operator, comma and dot operator. In the next session, we'll learn operator precedence and associativity types of expressions. Thank you.